Let's do a quick review of the topics learned in Chapter 4. So one of the things we learned to do was to graph a rational function. Okay. Something we should always do is factor, of course. So the numerator is going to factor into two binomials. Say we're going to have a 3 and a 1, right? We're going to have, minus 3 minus 1. The denominator factors into x plus 5, x minus 5. Okay, I'm noticing nothing cancels, so we're not going to have any wholes. Okay, the denominator is going to tell us our domain, so we're allowed to use all reals for this problem, except not plus and minus 5. Okay, so what is happening at plus and minus 5? There's no graph. Okay, there is a vertical asymptote, so the domain can split into these two things right here. And since neither of them are wholes, they're both going to be vertical asymptotes at plus and minus 5. Okay. How about the end behavior? The end behavior is determined by looking at the powers. The power of the numerator is equal to that of the denominator. So we're just going to take a look at these leading coefficients right here. And I've got y equals 1. Okay. The x-intercept can be found by setting y equal to 0, or even quicker, just looking at the factors of the numerator, setting that equal to 0. Numerator equal to 0. We're going to get 3, 0 and 1, 0. And the y-intercept is found by letting x equal to 0. I think it might be easier here to just let all the x's be 0. And then we have negative 3/25. Wow, that's going to be real tiny. Okay, so what is something like this going to look like? Let's go ahead and get a little piece of graph paper going. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we've got vertical asymptotes at plus and minus 5. Okay, we've got an end behavior of y equals 1. So we'll go ahead and get y equals 1 on there. There's a 1. Okay, we do have some intercepts, so let's get those guys graphed. We have 1 at 3, 0, and we have 1 at 1, 0. And the y-intercept is tiny. Okay, it's real tiny. It's not even negative 1. Super, super tiny right there. Okay, so I'm going to connect the dots here. I'm thinking the graph's going to go like this, cross up, cross down, and then we'll follow this asymptote right here. Down, down, down on the left, up, up, up on the right. None of these x-intercepts have multiplicity, so nothing is going to be brushing. They're all going to cross. Neither of these have multiplicity, so it's going to split. Let's go ahead and follow the end here. Okay, here, there's no x-intercepts, so I think I'm going to go down, down, down on the right. I have to go up, up, up on the left, and I'll follow the end behavior this way. Okay. That's what a rational function is going to look like. You have to be able to find all the stuff. Doing everything like this would not be a good finals question. So I might say find the graph or find some stuff. Or maybe if you find stuff, you might be able to pick the graph without doing everything. Okay, but make sure you know how to do all these things. Something else that was in Chapter 4 was when we did polynomial functions. Okay, so this is a polynomial. There's some things that we know about this. In order to factor this, we're going to make a list of PRZs, possible rational zeros. So you write plus and minus the factors, okay, of the constant, plus minus 1, plus minus 3, and you divide that by the factors of the leading coefficient, which is just plus minus 1. So those are the PRZs. I'm going to go ahead and start with 1. Okay, you take the coefficients, but you have to make sure you have one of everything. Power of 4, power of 3, power of 2, power of 1, to the none. Okay, you drop it down, and then you multiply. 1 times 1 is 1. Add the 2, you get 3. 1 times 3 is 3, plus negative 4 leaves me with a negative 1. Negative 1 plus negative 2 is negative 3. Oh, and it's working. As soon as you get something that works, okay, you're going to go ahead and write this in factored form. Okay, so we're going to write f of x equals. Okay, you're going to take this factor right here, remember, and you have to change it. You always have to change the 0 into minus, or the opposite. And then This started off as x to the fourth, so my answer is x to the third plus 3x squared minus x minus 3. Okay? Whenever you try to factor, always look for factoring by hand. Okay, I could keep testing, but maybe I could do grouping. Let's see. Is there something I could take out of here? 2x's maybe? And if I take a negative out of here, it looks like factor by grouping might work. Okay, so each and every time you want to write f of x, don't lose this factor. I'm going to use some brackets here to organize my grouping. I'm going to take out x squared, that gives me x plus 3. Take out negative 1, that gives me x plus 3. I could tell that it's working. Okay, so f of x is going to be x minus 1. The x plus 3 factor, that was the same. And then we've got x squared minus 1, which I'm going to write as x plus 1, x minus 1. Okay, factor difference of squares. So this would be factored form. If it said list the zeros would be, let's see, 1 comma 0, negative 3 comma 0, negative 1 comma 0, oh, and 1 again. Okay, so right here I'm going to say that the multiplicity is 2. Here the multiplicity was 1. Okay, so we had a repeat. What's so important about a repeat? Okay, when you have multiplicity that's even, it's going to brush. These guys here are going to cross. Okay, so we've got the factors, got the zeros. Now we're going to take a look at the graph. Well, let's go look at the beginning of the problem one more time. Since I see a positive x to the fourth, okay, the end behavior that you would say on the answer line would be y equals positive 1 x to the fourth. That's how you officially say it on the answer line. In my mind, I'm thinking up, up. That's what I have to draw. Okay, so let's go get our x-intercepts on here and everything. So we've got 1, 0. We've got negative 3, negative 1. Okay, how about a y-intercept? The y-intercept can be quickly found by looking back at the original problem. Okay, y-intercept is 3. 1, 2, 3. Okay, I'm going to start my ends by going up, up. And I'm approaching negative 3. I have to cross it. Cross negative 3. Okay, I'm approaching negative 1. I'm going to, cross that one. Cross. Make sure I grab this y-intercept. I'm approaching 1. I'm supposed to brush it. Perfect. That makes my ends go up, up. Okay, so you have to know all about polynomials, how to factor them, how to multiply them, and how to graph them. Okay, but the final is multiple choice, so hopefully that will help. Let's see, what else did we cover in Chapter 4? Being able to factor over the complex. Okay, so complex means real and imaginary. Real and imaginary. If you need to use i's, go ahead. Okay, it doesn't necessarily mean that there will be any, but if you need to, go right ahead. So this is a difference of squares. Okay, I know it's going to be plus 1 and minus 1. How does the beginning factor? So I know it's x and x, so what you're doing is square rooting, and that's what you do to 2. Square root of 2, the x is not in the radical, plus 1, radical 2, x minus 1. Okay, how would I factor this? Well, that's going to be imaginaries. X plus 3i, x minus 3i. If you need help figuring out how to factor that, you could always go do the problem by hand. Okay, you could say x squared plus 9 equals 0. And then you move the 9 to the other side, and then I notice when I square root, I'm getting a negative. And so that's going to be plus and minus 3, but then 3i. Okay, let's take a look at this last one right here. Does this factor? Oh, this is really weird. It's kind of like the beginning here. I know it's going to be radical 3x times radical 3x. Now, since it's a sum, it's going to be imaginaries. So it's going to be plus and minus. That is not a perfect square, so it's not going to be like a 3. It's going to be more like radical 5 but with an I. Weird. Okay, let's take a look at how to write a polynomial. Okay, the most important thing here, okay, polynomial means many terms. And how do you make many terms? Okay, that means you have to multiply it out. Okay, not just make it, but multiply it out. The first thing I'm going to do here, when it says 3 plus 2i, you need to add on another one. Buy one, get one free. I actually told you that there's also 3 minus 2i. Okay, so the leading coefficient is 2. So y equals 2. And then I've told you 2 zeros. So there's only going to be a degree of 2. You have to make sure that you change. X minus 3 minus 2i. X minus 3 plus 2i. Okay, there we go. And we're going to try to use that nice technique that I told you about in class, just to be more elegant. Okay, so this is going to be the A thing. They both have x minus 3. Then they have minus 2i plus 2i. So A minus B times A plus B can be simply done if I do A squared minus B squared. Let's try that. Okay, so y equals 2. You just hang on to a second. Okay, we're going to do the A thing squared. Don't forget about first, outers, inners, last. It's x squared minus 6x plus 9. That's the A thing squared. Okay. Now we're going to minus the B thing squared. 2i times 2i is 4i squared. But when I say I squared, you say negative 1. So this is actually going to become plus 4. So let's go ahead and let's do it all at once. Let's just go ahead and distribute 2x squared minus 12x. This is actually 13 times 2, and that's going to be 26. Okay. Multiplying out to make a polynomial. Okay, the very last thing that we studied in chapter 4 was solving inequalities. Okay, but whenever you have fractions or quantity squares, you have to do a number line. Okay, so first of all, let's get everything over to one side. I've got minus 12 over x minus 1 less than or equal to 0. Okay, and the only way to add or subtract fractions is to make common denominators. So I see that the denominator, the only one I see is x, so I'm going to make the common denominator x. So he needs to get multiplied by x over x. He needs to get multiplied by x over x. So the common denominator is definitely x. And how about that numerator? X squared, I'm going to write it in descending order, minus x minus 12. Okay, now it is a rational function. One numerator, one denominator. What do we have to do to that numerator? It's your favorite thing ever. Let's factor x minus 4, x plus 3. Okay, and the reason we factor is we could put the critical points on a number line. So I've got 4, negative 3, and then what number does that give us? 0. And now we have to figure out if we're going to put open bubbles or closed bubbles. If it comes from the denominator, you never want to equal 0. So that one's going to be open. Okay. The ones that come from the numerator depend on this sign, and since it's equal, those are going to be closed. Okay. And now we have to test 1, 2, 3, 4 sections. We have to find numbers that are in there so we can actually test those sections. Okay, so let's take the number, I don't know, negative 1. Okay, negative 1 minus 4, that's going to be a negative. Negative 1 plus 3 is a positive, and then divided by a negative. That's going to make a positive, but we want negative. That's not a good section. Okay, let's take a number in here. Maybe I'll take 1. 1 minus 4 is going to be a negative. 1 plus 3 is a positive. And then we've got a positive. That makes a negative, and that's what we wanted. So this is a good section. Okay, let's take, how about the number 5? 5 minus 4, positive. 5 plus 3, positive. Divide by positive. No, that's not going to work, okay? Because what we want are negatives. So we're trying to find the areas on the number line that give us negatives. Okay, let's take a look down here. Maybe I'll take negative 10. Go big or go home, right? Negative 10 minus 4 is negative. Negative 10 plus 3, negative. Negative. Negative times negative is positive, so 2 of them will cancel, but I still have 1 negative. Perfect, I wanted negatives. Okay, when you go ahead and write your answer for something like this, closed points are brackets, okay, and then open parentheses are the bubbles are open. So we have from negative infinity to negative 3, and then union 0 to 4 with brackets. And those are the sections that will work. That's where this function is less than 0. And that's a recap of chapter 4.